Okay students, let us try to solve this question. The question is, calculate the total number of electrons present in 1 mole of methane. Okay, so this is the first question about methane. So let us try to solve the first part of the question. Now you know that methane has got the formula CH4. Here they are asking you to find out electrons in 1 mole of methane. So let us first see that how many electrons are there in methane. Okay, so 1 molecule of methane, that is CH4, contains electrons. How many electrons? So you know that the number of electrons is nothing but the atomic number. So here carbon has got atomic number 6, so it will have 6 electrons into it. Plus you have hydrogen's atomic number is 1, but it has got 4 atoms here, so it is 1 into 4, so you are having 10 overall electrons present in 1 molecule of methane. So number of electrons are known. Now you need to find out that number of electrons in 1 mole of methane. Now we are aware 1 mole is Avogadro number, or that is 6.022 into 10 to the power of 23, which is nothing but 1 mole. Okay, that will contain how many electrons, that we are asked to find out. So will contain how many, so that you know, just multiply 6.022 into 10 to the power of 23 with this 10 electrons. So the answer you get back is finally 6.022 into 10 to the power of 24 electrons per mole. That is your answer. Okay, now let us see the second question. So second question is having two parts into it. You need to find out first total number, and in B part we need to find out total mass of neutrons in 7 milligrams of carbon 14. This is carbon 14. Okay, one of the isotope of carbon, and we need to assume the mass of neutron given here is 1.675 into 10 to the power of minus 27 kg. Fine. So here is the talk about the neutrons. So in part 1, in second part, part A, let us see that total number of neutrons in 7 milligrams of carbon 14. So first let us try to find out the number of neutrons in carbon 14, which is C14, and its atomic number is 6, so can be written like this. And we know that number of neutrons can be found out by subtracting the atomic number from the mass number. So 14 minus 6, you will get back 8 neutrons here. So you are having 8 neutrons in carbon 14. Now we need to find out the total number of neutrons in 7 milligrams of carbon 14. Now we know here that 1 gram atom of C14, that is C614, is nothing but 14 grams, right? 1 gram atom of carbon 14 is 14 grams, which is equal to 6.022 into 10 to the power of 23 atoms. Again I am telling, it's 1 gram atom, 1 gram atom. 1 gram atom of carbon 14 is 14 grams, so that is equal to Avogadro number of atoms into it. Now it is 6.022 into 10 to the power of 23 into 8 neutrons. So that is the number of neutrons in 1 gram of carbon 14. Now we are given 7 milligrams. We are given 7 milligrams here in the question. So let us try to find out in 7 milligrams how much you will have. So just now we saw that 14 grams which is nothing but 14,000 milligrams, will have your this 6.022 into 10 to the power of 23 into 8 neutrons. You will have that much in your 14 grams. Therefore, your 7 milligrams, which is nothing but equal to, that is, you will have 7, okay, it is in milligrams we have already taken. So 7 milligrams will have how much? Directly we can take. So you just have to multiply. Let me rub off this particular part. So we don't need this. Fine. So let us try to just multiply 7 into this 8 into 6.022 into 10 to the power of 23 divided by 14,000 as it is in milligrams. Now when you will multiply 7 eighths, that is 56, multiply it with 6.022, then divide by 14,000. So you will get back 0.024088 into 10 to the power of 23. Let us try to shift the decimal point between 2 and 4. So you are moving towards, right, 2.4088. So that has to be multiplied by 10 to the power of 2. So when you are shifting the decimal point between 2 and 4, so when you multiply it with 10 to the power of 2, that is minus 2, so it is written as 23 into 10 to the power of minus 2, as you have shifted 2 digits towards the right. So answer ultimately is 2.4088 into 10 to the power of 21 neutrons. Now this is your answer, that 7 milligrams of carbon will have this many number of neutrons. This was part A which we solved. Now we need to solve part B, that is total mass of neutrons has to be found out. Total mass, that was the number we have found out. Now we will be finding out the mass. So here in this part, B part, you need to find out the mass. Now here you can see that mass of neutron we are supposed to assume as 1.675 into 10 to the power of 27 kg. So let me write over here. It is mass of one neutron you need to assume as 1.675 into 10 to the power of minus 27 kg. So therefore your mass of whatever neutrons you had, you have just now found out this 2.44. So let us find out the mass of 2.4088 into 10 to the power of 21 neutrons will have what mass? So you just have to multiply. So you will get 2.4088 into 10 to the power of 21 into 1.675 into 10 to the power of minus 27 kg. So you will multiply 2.4088 with 1.675, you will get 4.0347 into, you see that you add the powers. Okay, here 27 is greater, so your answer would be in minus. So it is, this is 21, one is 27. So you just subtract, you will get 10 to the power of minus 6. Minus is because 27 is greater. So you have answer as 4.0347 into 10 to the power of 6 kg is the mass of this many neutrons, that is 2.488 into 10 to the power 21. Or you will see that 7 milligrams were having this many neutrons, and this mass of this neutron is found out finally to be 4.0347 into 10 to the power of 6 kg. So again, if we look at, we are done with this particular second part of the question. Similarly, you need to do one more part of the question, that is third part, and it is exactly like your second one, but here the question is you have to find out total number and total mass of protons, and that too of 34 milligrams of ammonia. Okay, so let us try to solve the third part of the question, and it goes like protons need to be found out. So let us see that A part is number of protons in ammonia. Okay, number of protons in ammonia formula is NH3. So that will be equal to the atomic number of nitrogen here is 7. So number of electrons also would be 7 plus atomic number of hydrogen is 1. But you are having 3 atoms of hydrogen, so 3 electrons. So you have total 10 protons. Okay, here we are talking about protons. So whatever is the atomic number is the number of electrons and protons because it is neutral. Fine. So that is the number of protons in ammonia. Now we know that 1 mole of ammonia, 1 mole of NH3 is nothing but 17 grams because 17 grams is the mass. Nitrogen has 14 and hydrogen has 1 into 3. So 14 plus 3 will be giving you 17 grams. This we are aware of. And that 17 grams will have Avogadro number of molecules. So 6.022 into 10 to the power of 23 molecules are there in your 17 grams. So how many protons you will have in this molecules or 17 grams? You just have to multiply it with 10 protons. So 6.022 into 10 to the power of 23 into 10 number of total protons you will have in 17 grams. That end up in 6.022 into 10 to the power of 24 protons. Okay, these are the number of protons in 17 grams. So 17 grams has this protons. Now how many grams are we given? Yes, we are here given 34 milligrams. Here you can see it is 34 milligrams. So let us try to find number of protons now in 34 milligrams. Therefore 34 milligrams, or as we are having 17 grams, let us convert this 34 milligrams into grams. That comes out to be 0.034. Milli is 10 to the power of minus 3. Okay, so you just multiply this with 10 to the power of minus 3. So 17 grams has this proton, so 0.034 grams of ammonia will have how many protons? So again it is, you need to multiply 0.034 into 6.022 into 10 to the power of 24 and divide by this 17. So you see, on multiplying 0.34 and 6.02 you get back 0.2047 into 10 to the power of 24. Then you divide it by 17. So here you will get 0.012044 into 10 to the power of 24. Again let us shift the decimal point after 1 or between 1 and 2. Here you will have 1.2044 into 10 to the power of 24 into, as you have shifted 2 decimals, here it will be minus 2. So ultimately the number of protons which you get back will be into 10 to the power of 22 protons. So this was the number of protons in 34 milligrams which you have found out. Okay, fine. So that was the total number of protons. Now you need to also find out the mass in the other part, and the mass of proton for reference is given to you as 1.6726 into 10 to the power of 27 kg. So as we have just done above for your carbon 14, similarly you have to do over here. So let us see that. You proceed with the B part. So here we are supposed to assume, they have said, so let us see, mass of one proton they have asked us to assume is 1.6726 into 10 to the power of minus 27 kg. So therefore we have just now found out the mass of 34 milligrams of proton. So this mass will have what weight? So mass of 1.2044 into 10 to the power of 22 protons will be weighing how much? So again here you just need to multiply. So let us see, 1.2044 into 10 to the power of 22 into 1.6726 into 10 to the power of minus 27 kg. Okay, you need to multiply this too. Here when you multiply 1.204 with 1.6726, you will get back the answer as 2.2 2.0145 into, you see that you are taking these powers also into consideration, adding them, and here 27 is with minus 27, so you will just have to minus 22 from 27. So you will get 10 to the power of 5, but as 27 is greater, the minus sign has to be there over 10. So it is 10 to the power of minus 5 kg. So that is the mass of 1.2044 into 10 to the 22 protons. That is the final answer. Now one more small question is there at the end. If you will see carefully, it is, will the answer change if the temperature and pressure are changed? So for this, finally, let me tell you, there is no effect of temperature and pressure. There is no effect of temperature and pressure. That is the answer for the whole question, which is divided into 3 parts. So you just have a look at a glance. 3 parts in one question can be solved in this particular way. I hope you have understood. See to it that you are practicing continuously all such type of questions. Thank you all.